So now that you guys have watched a little bit of videos and gotten some preliminaries on how to do some data setup in your graphing utility, what you'll do is you'll watch me pretty much do the same thing, press some of the same buttons to basically do some 4.2 like work. So you can see what I have here first of all is a table of data. So let's begin by using our graphing utility to basically see that data and to plot it. So again, to do that, we're going to come over to our calculator. Hopefully that glare is not going to be too much, right? We're going to turn it on. What I need to do is input this into a list. So the list is the secondary function of the stat function. So we'll press second and then list. Basically what I'd like to do is to, excuse me, I'm doing something else. So let me quit. I need to just press the stat button, right? And what I need to do is edit. So press edit. Right now I have some data in there, so just highlight, press your arrows up and highlight L1, and you can clear that out. Press clear and enter, right? And then same thing up here, highlight L2, press clear and enter, and that clears them out. My L1 list is -4, -2, press enter each time, 0, 2, and 4. Right, and my second list is -7, enter, -5, -1, and 0, and 3. Make sure that the number of x values matches your number of y values, which they do here. And so now what we'd like to do, right, is we'd like to get the calculator to visualize that. So we can press second quit to get out of there. What we need to do is go ahead and press y equals. And if you go up here, you'll see that there's plot 1, plot 2, plot 3. Those are our statistical plots. None of them are highlighted. So let me go ahead and just press enter to put plot 1 on. Of course, to manipulate it, I'll go to second stat plot. You can see that it is actually on, but you could also press enter here. You could press it on here. What it's doing is taking the x list of L1, the y list of L2, it's putting it as a scatter plot. You can change that if you'd like as well, and it's using a little box to represent the data. So when I go graph this, right, there's basically the data. It's all within the nice -10 to 10 and -10 to 10, so it fits really nice on our standard viewing rectangle. And we can see that it's not exactly a line, right? There's kind of a little bit of a ripple there, but it does in fact, right, it does appear to be linear, although it's not an exact line because of that little ripple. Of course, we can see that. Notice that each change in x is 2, right? So the change in x is equal to 2. We went up by 2, and then we went up by 4, and then we went up by 1 and up by 3. So the change in y is not constant. So we didn't expect a line, and that's kind of what we're seeing. We're not really seeing a nice perfect line, but it is behaving like a linear, a line going up. Okay, so let's go ahead then, and the first thing, let's do some algebra. Let's pick 2 points and find a linear model that contains it. Now this is going to vary from person to person because the data is all over the place. Your 2 points might be different than my 2 points, and so there's a million different answers here. But what I'm going to do is, how about I just pick the first data point and the last data point to find a linear model. Of course, what I need, right, is f of x equals mx plus b, but we don't have a y. Oh, we do actually have a y-intercept there, so we know the y-intercept is 0, -1, so we already know what b is. I just need to find the slope. Oh, actually, let me correct that. Let me go ahead and rather than using that point, let me use this point and this point. That way we have the y-intercept. Sorry, I'm making all kinds of goofy mistakes. So the slope, right, between these 2 points, we're going to take 3 take away -1, and then 4 take away 0. And so my slope for this line looks like it's going to be 4 over 4, so it's 1. So my model, right, would be x minus 1. So that's basically what I'm saying the model is. I can come back to my graph, and I can go to y equals, and I can type in, x minus 1. I can plot my fit to that, and you can see that it's only really good for the 2 data points that I use to fit it, right? The y-intercept and that data point, but it's way off on the other ones. All right. Well, luckily, right, what the calculator does, that's just for some good review of finding linear models. But what the calculator will do is find a linear regression, as you saw in the videos. The linear regression is the best fit. All right. It's the closest fit to all the data that we can have. So it might not hit any of them, but it's going to be a lot closer. Like right there, that's a pretty bad fit and a pretty bad fit, and not so good fit. So my line is not that great. So how do we do that? We go back to stat. This time we go to calculate. So I want to, oops, dang it, wrong thing. We'll go to stat. We want to calculate. We want to calculate a linear regression. All right, and so the linear regressions for the L1 data, and for the Y, it's the L2 data. I actually do want to store it so we can graph it. So if I press the F4 button right there, we need to press alpha F4, and that'll give me all my little Y1, Y2, Y3, and Y4. So let me put it in Y2 since we have my model in Y1. Okay, and then just come down here and press calculate, and it brings it out, and there's basically the model. Right? So our model, according to the linear regression, they're calling their A is our slope, right, and their B is our y-intercept. So they have 1.25x, right, minus 2 is their model. So to graph that regression line, we could do two things. We can come back to y equals, and notice because I had the graphing calculator store the regression model in Y2, it's already done it. Or you can just physically type it. So there's my model, there's the equation model. When I go graph them together, right, there's the data, there's my line, and there's their line. And you can see it clearly is a much better fit. So if I was going to do any analysis, like to do some predictions later on, like we're going to do in a moment, I would probably want to use their regression model rather than mine, all right, because it's obviously a much better fit. And that's actually our next thing. We want to use your model and the regression model, predict the value at x equals 10. So we can kind of see 10's way out here. So how about I first change my window, and let's go out to about 15 along the x-axis, and how we go about 20 on the y-axis. So there's my graph, right? There's my data. There's my curve. There's the linear regression curve. And so when we basically calculate the value of 10, right, I want x equal to 10, it will actually do both. So notice right now the cursor is on my graph, right? So it's giving an output of 9. So for my prediction, if f of x is equal to x minus 1, of course, we can kind of see that 10 minus 1 equals 9. So it's just verifying something that we already know. To do the regression model, right, the regression model, f of 10 would be 1.25 times 10 minus 2. And of course, this would be 12.5 minus 2. They're going to get a 10.5. So we can just, how about we do that? So rather than going through all that, if we just press the arrow up, notice it's now, right, the cursor is sitting there on the regression analysis data, and it's giving me a value of 10.5 like it should. And again, I'm trusting this guy more than this guy just by the pure fit. The data that's presented, the linear regression, fit it so much nicer. So there's some analysis, doing some old stuff, right? Old school algebra, doing some new school algebra by using the calculator, and then modeling, finding some values with the calculator. So hopefully watching me press some buttons helped out. We'll do some more to kind of get you practiced up and ready to go. See you in the next video.